Hey Brian, what's up?
Hey Adam.
Oh, what's this?
Adam, what are you doing? Adam!
No!
Guys, I'm Jason. Brian's gone. I don't know. Just go to Kahoot. We'll get this figured out. He sent you the information. It's on Canvas. It's on YouTube. Just go to Kahoot. I don't know what we're gonna do, but we're gonna figure this out. It's gonna happen. That's all I got. Just go to Kahoot. Thanks. Ugh.
Stat 201.
Hey Brian, what's up?
Hey Adam.
Oh, what's this?
Adam, what are you doing? Adam!
No!
Hey everyone, Jason here. We've tried to find someone to do the Kahoot. You know what though? We could just try and bring him back. I happen to have this. So we'll see what happens.
Oh my gosh, not chain t-shirts between the scenes. It's impossible. What's going on? How's everyone doing from the portal of Scatterplots? That's the Scatterplot dimension behind there. This is going to bring back Iron Man 2. It will bring back Iron Man. Amy, you know what's up right there. We are back from the portal dimension. Let me turn off the portal. That way it doesn't happen anymore. With that, Walking W, thank you so much. Let's turn to the main screen and start some Kahoot. Rachel, thank you so much. 100 points for all the positivity. Mewbots in the chat right here. We're going to start Kahoot in just a moment. Hopefully people are enjoying themselves. We'll turn up the disco Kahoot music. We're going to do about 2 minutes. Then we're going to Kahoot. Make sure to scan the picture. We got Gia here, lion with pancakes. How'd that lion get pancakes on its head? I don't know. How many people are we going to have in the Kahoot? I hope we have 100. Show me 100. Can we have goofy names or our names? It'll do a random name generation, I think. Whoops, I didn't do random name generation. I think we're good. Okay, wait. Okay, so I'm gonna do one thing. I'm restarting just in case, because I have had. So we're doing one thing. Brian made a boo-boo. Brian made a, oh, whoops-a-daisy. So I forgot we use Kahoot. Good to see everyone there. Eric, I think that's, what's Mewbot doing? What's Mewbot doing? Brian was getting everything ready and he forgot. He changed things. We're gonna restart the Kahoot real quick. The reason, since I do this on YouTube, I don't do it with the general, you can pick your name. Sorry, everyone. So restarting the Kahoot, and I need to put on the name generation is not allowed. Not too late to join at all. I'm just resetting the Kahoot right here. So I have to put on nickname generator, and now we're good to go. Okay, so restarting. Sorry about that, everyone. The Kahoot code's gonna be back on the screen, but please join in. Just because, since we're on YouTube, sometimes we get people who like to play funny games. Eric, good to see you here. Good to see you in the chat, Eric. Please join in. Sorry, we had a reset right there, but please join the Kahoot code and make sure to do that. Look at that. We got so many people right here. Love it, silly mouse. Everybody join in. Let's get our disco music back in here. We got disco music back. Can we hit 100 players? We'll give it about 2 minutes right now, and then we'll try to hit 100. Evelyn, good to see you. Gail, good to see you. Gail, good to see you. Joe and Landon, might we hit 100? We used to have 200 or 300 people playing Kahoots. We used to get 200 or 300 people playing a Kahoot. And let me tell you this. Have what next to you? Have what beside you right now? Now, these aren't quite this, but I would have these beside me. What should you have beside you? This is recorded, so you can come back to it at any time. What should you have beside you? Notes, note cards, and notes. A lot of the things I'll be going over, we're about to hit 100, worth 100 points if you're one of my students. So thank you, everybody. We're right about to hit 100 players, and I love that. That makes me smile when we hit 100. And tell everyone, if you do well with the Kahoot, if you think the Kahoot was beneficial, tell your friends. Be like, you know, you should join the Kahoot. There's gonna be prizes. We have Kahoot t-shirts. We are running low on sizes, but we have Kahoot t-shirts. Kahoot t-shirts. Thank you to Kahoot. I would take note cards just to take notes. Kahoot t-shirts. Woo! Kahoot t-shirts. I'll probably unplug a wire. We got Kahoot t-shirts, and also for first, second, and third, we will be doing $20 gift card for first, $20 gift card for second, and $10 for third. So, and that can be Starbucks or Amazon, your choice. Make sure to email me from your UTK email account. Probably take a screenshot or anything of your win, first, second, or third. And then we can also give out a t-shirt. So I'm also giving out the Amazon Starbucks because I might not have your size. You might be like, I want a medium, and I'd be like, I only have a XL or XS. So yeah, need one of those Kahoot t-shirts, a nice purple t-shirt. I have one to keep one for myself so I could wear a Kahoot t-shirt. Shout out to Kahoot. Do love their product. Excellent stuff here. So how's everyone doing? Everyone saying hey in the chat. We're almost at 100. Tell people. We're gonna start here in 1 minute. I'm starting a 1 minute timer. So if you're wondering when this is gonna start, it'll start. Where's my timers at? There's my timer. 1 minute on the clock. Then we'll get started. The Kahoot will be about an hour, hour and a half. I think I'm on means at when? 1:30? The Kahoot will cover a lot of general ideas. I don't remember if there's a pivot question. Pivot tables and pivot charts are not on the test. And I don't think I put in a pivot chart question. I will say this, there are some tricky questions, and I'll give you a huge hint. Whenever you look at box plots, do not forget to look for what's. I'm already helping you out the Kahoot. Like, you should have this note, and when we get to this question, I want you to get it right. But if you get it wrong, don't forget, whenever you look at box plots, and you're looking for things like range, Amy already knows it, look for outliers. That's gonna come up in the Kahoot. So be ready later on when you're like, oh, wait, I should look for them. You might not notice them. They might be extreme. They might be far away from the rest of the data. With that, we need one more person. Show me one more Kahooter, and then let's get started with 100. Also, stay till the end if you can. We have a lot of people drop off. Don't worry if you're getting things wrong. If you're getting things wrong, it means you're learning. If you get everything right, why are you here? It means you're gonna win. Okay, give me an I'm ready in the chat. The woman has passed. I need some I'm readies. I'm ready. I'm ready. Woo! Where's my I'm readies? Where's some I'm readies? You say we have to figure out Q1 and Q2 by hand. You don't have to figure those out by hand. We got some I'm readies in the chat. Here we go. In 3, 2, so many I'm readies worth 100 points. 1, let's Kahoot. First question of the day. A lot of I'm readies. 3, 2, 1. Which of the following phrases helps identify quantitative variables? So think about when you're dealing with quantitative variables, a quantitative variable is actual real numbers. One thing you can do with quantitative variables is you can do math. So whenever someone tells you an answer like 3, you know it's quantitative, you can add another answer. Like, how many math courses have you taken? Someone says 3 and someone says 2. Well, together they've taken 5. But if someone says I'm in group 3 and someone says I'm in group 2, that's not quantitative because you can't add it together to find out together they're in group 5. Right? Quantities or quantitative variables are a how much. And another trick you can do is you can always subtract them. Think about, like, if I say I'm 75 inches tall and my wife is 60 inches tall, what could you do with 75 and 60 and talk about in context? Like 75 and 60, what could you do in context? What could you do to, like, think about how it's quantity of height? What can you do? This is a good way to check quantities also to see if they're a quantity. If things are quantitative variables, what can you do? No one knows? 75 inches, 60 inches. What can you do with those numbers? You could add them, and it doesn't really make sense. And I would subtract them. Good answers right there. I would subtract them, or you could average them. I like that. You might not add two people's heights, but you could say the difference between the people's heights. Notice how all these things are mathematical operations, and we can do that with quantitative variables. So all these, great job, Rachel. We're making Rachel an honorary mod right here. So we can do mathematics with quantitative variables. Be careful though. This will come up later too. Not all things that are numbers are quantitative. Like imagine if your teacher says you're in group 1, you're in group 2, you're in group 3, you're in group 4. That's not a quantity of your group. Or if you label your state, like Tennessee is state number 40, well, state Tennessee is not a quantity of 40. It's just the 40th state, whatever we are. We're probably more like 18th state. Brian knows Tennessee history, not. But that's not a quantity of how much our state is. It's just a numbering of the state and put into a ordered group or something like that. It's not a group. It's not a quantity anymore of state quantity. It's just state number this. It's not a quantity though. Okay, let's check out that leaderboard. Leaderboard has Captain Ant at the top with Glowing Alpaca, Super Sphinx, and Expert Hare, and Polite Sloth. I'm always rooting for those hares right there. Those bunnies are my favorites, but Polite Sloth, you look pretty cool. Next one, Zip Code 2. More on that in a moment. Good answers in the chat. The University of Tennessee uses your student number, like 239, to track you in databases. What kind of variable is this? This is a very unique type of variable. Now, there's a technical thing here. It is a special kind of these, but it is specifically a this. So who knows? It is a special kind of this. That's not the answer. It's so special, we give it a unique name. So we're doing additional questions here as this question is on the screen. So think about these additional questions like, this is a special kind of what? You'll say in the chat. The answer is identifier. And it's not a special kind of identifier. It is a special kind of categorical variable. Now, what makes your student ID an identifier? What makes your student ID an identifier? Why, it's right there. What makes your student ID an identifier? Like if they're looking you up and they're saying, oh, we got to find your class schedule, and they say, what's your student ID? What makes that an identifier? It is you, it is unique, it can never repeat. And it is true that identifiers are special case categorical variables, but in data frames, the unique identifier can never repeat. And that's where the way we usually use identifiers. You might see things that say they're identifiers, but the truest form of an identifier is a special case categorical variable that will never repeat. Now be careful. If my brother and I go and get ice cream, and I get chocolate and he gets strawberry, since chocolate and strawberry has not repeated, is that an identifier? So I get chocolate, Darren gets strawberry. Is that now an identifier because it doesn't repeat? It's a categorical variable that doesn't repeat. Is it an identifier? No. And we'll throw 100 points. Remember, all answers get points here. Why is it not an identifier? I thought identifiers don't repeat. The biggest thing about identifiers is they could... No, Catherine, we're throwing you 100 points. Remember, you get points for all these answers right here. It's because it theoretically... I want some W's in the chat because I'm hitting that 100 points in extra time right here. We answer all questions right here. Another 100 points for everyone, if you're in my class especially. Put some W's in the chat. The reason chocolate and strawberry wouldn't be identifiers there is because it could repeat. So it's not that it doesn't repeat, which is a fact. That is important. It's that it would never repeat. So as long as Tennessee is giving out student IDs, we shouldn't repeat. We should just, no worries, Ryan. Glad to have you here. 100 points for Ryan being here. As long as it could never, ever repeat, no matter how big the data set you make, it's going to be called an identifier. As W's in the chat. So with this right here, an identifier is a variable that can never, ever repeat. It's a special case categorical variable. It can never repeat no matter how large the data set gets. So a good check of it is to see if it does repeat. Thank you so much, Rachel, right there. Love the positivity and glad these videos are helping out. We've got here Captain Ant, Arctic Tiger, Glowing Alpaca, Super Sphinx, and Bright Otter with a 10-point difference. That's what I think. That is cool. Let's do the next question. Here we go. A blank is a group of people or items that we want to understand. Now, be very careful. A lot of these terms are super close. A lot of these terms are super close. We're going to define each one of these on the next screen, so have your note cards out to be ready to define all of them. Be ready to define every single one of these with examples coming up in just a second. So if you've already answered, go and grab a sheet of paper or some note cards to write down each one of these terms. And I'll probably bring up a little bit of paper right here. A little bit of paper never hurt anybody, unless you get paper cut. Okay, a lot of people said sample. Let's talk about it. Okay, the answer is population. We'll talk about the tips right here for the exam. We've got a billion documents, we'll just close out of those. Okay, so population is a group of people or items we want to understand. Sometimes this is called the population of interest. That is just added on. It means the same thing. Think about what it means to be interested in something. You would want to what? Think about why we would say a population of interest. Because we might what? Think about why it makes sense to call it a population of interest. We're like interested in it. Does that make sense? Say it in the chat. Like, this is a population of interest. What does that mean? Your mom bakes a cake. And you say, Mom, a cake is the population. And your mom says, I get it. You want to what this cake? There's the cake. Put a little icing on it, make it look better. Your mom says, you want to what this cake? Your mom says you want to what this cake? I am not an artist. I want to understand this cake. We are interested in the population at hand. The population is the thing you want to understand. The people or things or items you want to understand. So it's called oftentimes the population of interest, art, lack of it. And so how do we make it? Well, the population is just the thing that exists. It's a thing that's out there. That cake is out there. But what we do is we go and we take a what of that cake. You say, Mom, I seek to understand it, and I will take a what of your cake. So this is our insight into the population to estimate truths about it. So this is our insight. You say, Mom, I'm going to sample that cake. And how do you sample a cake? You take a slice of the cake. You go out there and you just take a slice of that cake. And there you go. Oh my gosh. I actually drew something that kind of looked like what I wanted to draw. It is man, we just got to do a little excitement right there. Because well, sure, we'll put that icing. There you go. This is a good slice of cake right here. Oh man. It'll be the best drawing I've ever done. And then you got to do the little, we're going real on this. Look at this. Wow. Okay. You say, I want that slice of cake right there. Just give me a slice of that cake. So with this, the sample is our insight into the cake. The cake slice is our insight to understand the population of interest. Now from samples, you'll hear me say SSPP. What in the world is SSPP? Because SS means sample what's-is. Samples give us what's-is. Samples gives us what's-is. A sample would lead to, good guess on size right there. Let's throw points. We do have a sample size, and that's a bigger slice there. We have sample, oh my gosh, Diana with 100 points right there. Diana said it as a phrase, sample statistics give insight into population parameters. And that's all the words we just saw on the screen. Sample statistics give insights into population parameters. So now we have more words here that we got to make sure we know what they mean. If we talk about what is a statistic is an estimate of the truth obtained from a sample. A parameter is the truth for a population. So when you rate your mom's cake, your rating or your family's average rating is a what? When you rate your mom's cake, is it a sample, statistic, parameter, or population? When you and your family rate your mom's cake, because she's going to take it to a big event and she wants to know what people at the event are going to think. When you rate the cake, be careful, good answers, Jack, right there. When you rate your mom's cake and your family rates your mom's cake, it's a statistic. It's a sample statistic because you're all taking samples of the cake. Unless you say she wants to know what the family thinks of it, and then she would understand the parameter of interest, which is what does the family think? So the context here does matter because is she interested in what does the family think? And then if all the family eats it, we have information from everyone in the family and we can know the truth on what the family thinks. But if she wants to know globally, like what do people think of my cake in general, then the family is just a sample and maybe a biased sample of what people might think about the cake. and now what everyone thinks about your mom's cake, because your mom cares about everybody. Your mom wants to know, what does everyone think about the cake? So what everyone thinks of your mom's cake and how they would rate your mom's cake is the what. Not what everyone is, but what everyone thinks about your mom's cake. What everyone thinks about your mom's cake. Like the rating everyone would give to your mom's cake is the what. The parameter, great job, Thomas, right there. That is the parameter which is linked to the population. The population is the people who would try your mom's cake, because we want to know what those people think. And then what those people think, the truth of what they think, is the parameter. And your mom would get an estimate of what everyone thinks by talking to her sample, which might be the family, which is a biased sample technically, and then giving your family samples and getting statistics from those samples. Do these words make more sense now? I hope. We can do a lot of examples with these, but I hope these words right here with population, a group of people, of things we want to understand. The sample is going to be our insight or the collection of individuals we get to estimate the truth. And the statistic is obtained from the sample, and the parameter, thank you, Thomas, right there. The parameter is going to be the truth for the population, which is estimated by the sample statistic. Well, let's take a look at that leaderboard. No way it's still a 10-point distance. No way. All those M&Ms look so good. It is now a 15 or 16 point difference. Still pretty crazy. I am just, you know, in awe of this. My gosh, it is, wow. I think that was the right button. That was, I don't know. Let's continue on. Next question. How does a normal probability plot determine the probability something is normal? How does a normal probability plot determine if something is normal? Okay, we're gonna draw this out here in a moment. We got it on the screen. Where is my... There it is. Oh, maybe I did it right. No, it's down here. So the normal probability plot is this one. Now we have a trick to remembering what a normal probability plot is. You should read this. What? If you're in my class, what's the trick? Oh, good work. Great work on this answer. What's the trick to remembering what a normal probability plot is? Take where it says normal probability plot and do what? So take where it says normal probability plot and do what to it? Who remembers the trick from our class? To be like, I said, like, oh, if you're trying to remember what it is, look at normal probability plot and read it what? That was crazy. Look at normal probability plot and do what? That's actually a goodness of fit test. Good comments, Rachel. That's a goodness of fit test. If the p-value is high on the goodness of fit test, then we will continue to believe it's normal. If the p-value is low on the goodness of fit test, we have evidence to reject normality. I could show some of that too. And so with a normal probability plot, say it with me, it's a plot to help us determine the probability the data follows the normal. Read it backwards. So remember, just reading it backwards, plot probability normal, a plot that helps us understand the probability of something being normal. Now, when you have data, if data is normal, it's going to generally follow this line. This line right here is not a linear relationship. The line I can't reach is not a linear relationship. It's the perfect normal of the quantiles of your data matching up with the quantiles of the normal. Basically just saying it follows it perfectly. Now, if you look at the data down below, we should get this one right pretty quickly. That's a what skewed monster man. Who knows what tail this monster man has? You can see it pretty quickly. Right skewed, right to the high, left to the low, whatever way the monster man's tail goes. So we draw our little monster man and we write down here high, low, and this is the left, which is the negative, and this is the right, which is the high. So this is a right skewed monster man right there, and this is very much normal or very much not normal. This is very much normal or not. So you want to respond with either normal or not. This is very much normal or not normal. Not at all. Great job, Ellie, right there. This is super duper not normal. So when you look at your points, do the points follow the red line? Do you see these points here? Do those follow that red line? Like you told your friend, draw on the red line. Would you tell your friend good or bad job? So you said draw on that red line right there. The points do not follow, right? So that is evidence it is not normal. Now the histogram also shows that too, but it's a bad job. So since the points do not follow the line, we have evidence that the data is not normal. There is the goodness of fit test 2 that uses a p-value. We can take a look at that a little bit later. But the normal probability plot, say it with me if you want in the chat for points, is a plot that shows us the probability of the data being normal. When the data is normal, it'll follow the red line. And it can have little deviations, but the worse they are, the less normal it is. If it escapes outside of these bands right here, those are kind of the meh bands, and this one's super outside of the meh bands, so it's pretty bad. Normal probability plot shows probability of data being normal. Great job, Thomas, right there, getting us tons of points. Keep it up. Write down those answers. You got it. Leaderboard time. Classy Snail, Epic Swan, Bright Otter, Amazon Gecko, and Polite Sloth, being polite, just hanging out there in 5th, but you got this. Here we go with the next question. Which of the following graphics can be used for univariate categorical data? Now, there's some sayings we're going to have here in a moment. I pull up my best friend. Two answers on this screen should be eliminated super quickly.
This is a.
Oh, you know where it's going if you heard this in the background. Two answers on this screen should be eliminated. Great job, Jack, right there. Yes, Joseph. 100 points, Joseph already knows. Okay. So there are 2 right answers here. And I asked this of you. Please take a shot or screenshot of this graphic right here. Please write it down or screenshot it. This is very helpful for a lot of this test and for upcoming things in the future. But you might be wondering why there's arrows next to pie and bar chart. I say this. The reason there's arrows next to pie and bar chart is because of my favorite saying. I have the main. Oh, the music might have been pretty high. Oops, tell me if the music is ever too loud. So, oh, sorry everyone. I clicked one wrong button and I clicked like 5 wrong buttons. Here we go. Here's the saying.
This is a pie chart describing my favorite bars. And this is a bar graph describing my favorite pies.
Just so you can hear it again.
This is a pie chart describing my favorite bars. And this is a bar graph describing my favorite pies.
Now, why do I show you this? If you ask someone their favorite pie, go ahead and respond to that in the chat if you want. If you ask someone their favorite pie, what's your response? Tell me your favorite pie. Go ahead and favorite pie in the chat. Just go ahead and say it. What's your favorite pie? Just go ahead and say it. I like Oreo. Oreo's awesome. Coconut cream, good stuff right there. Key lime. Notice all your responses are what? Say it with me after you've said this. All your responses to favorite pie are what? Like asking someone their favorite pie elicits a what response? What kind of response is being elicited? Ooh, Jess, I think I had that one. Elicits a what response? Categorical. So by remembering bar chart of your favorite pie and pie chart of your favorite bars, you'll remember these are categorical up here, univariate. There's no extra variable involved in them. Paretos are bar charts put in order. Frequency tables are basically a univariate contingency table, and ring charts, no one likes ring charts, hence the sad face. Histograms, box plots, stem and leaf and dot plots are going to be your univariate quantitative, bivariate quantitative or scatter plots, and time plots are special case scatter plots with time on the x-axis. Side-by-side box plots and stacked histograms, which have the same horizontal and vertical axis, are going to be categorical X, quantitative Y. And then bivariate categorical are down here, with mosaic plots being the visualization and contingency table being the numeric values, and stacked or side-by-side values of bars or pies can be used. I'm not a big fan of those. There's a really great graphic right here and great practice, but remember, bars and pies go together. So if you remember, what's my favorite bar? You'll be like, oh yeah, barcade. That's categorical. And then pies are the same too. So good work. Don't worry if you got it wrong. Write it down. And once again, please don't leave. I mean, you can leave anytime you want, but if you're getting things wrong, you're learning. You're finding those weak points and getting stronger. So stay here, get stronger with us, and let's do the next question, or leaderboard first. We got Lucky Griffin. Nice job. Bright Otter, Epic Swan, Classy Snail, and Nimble Hawk. Next question. Okay. Which of the following graphs can be used for bivariate categorical? So that image is going to come in some use. Who knows the difference right here? 2 of these are what, and 2 of these are what? You just saw the graphics, so if you can go more in depth. 2 of these are what? And it wants bivariate categorical, like we're saying like favorite animal and year in school, like freshman, sophomore, junior, senior. 2 of these graphics are something, and 2 of these graphics are something else. Anyone finish that sentence? That's an additional review. 2 of these graphics are for what? Great job, Joe, right there. Nice job. 50 points, Joe. Scatter plots require 2 quantitative variables. Be careful. A lot of people call them dot plots. They're not dot plots. We'll see some scatter plots later, but a scatter plot is the visualization of 2 quantitative variables, and time plots just have time on the x-axis, like the year it was in Kentucky Derby race time. Those would be time plots, a special kind of scatter plot. And then contingency table is going to be where the numbers are inside the table, and mosaic plots are going to be the visualization of 2 categorical variables. Those are both bivariate categorical. Let's check out the leaderboard. Epic Swan, Caring Sea Lion, Classy Snail, Amazon Gecko, and Nimble Hawk. This is a super close game. I'm seeing people bounce around the leaderboard. Let's find out the next question. Here we go. Find the IQR of the distribution. I'm going to zoom in here. It'll be on your phone too to answer, but I'm zooming in so you can see it. You should know the IQR very quickly by looking at this. So look at that data right there and find the IQR. What is the IQR? Now, the point of this one is to see that you can get it visually. Where visually is the IQR on this? Can anyone explain visually the IQR is the what? Visually, the IQR is the what? Visually speaking, the IQR is the what? It's the box of the box plot. And great work right there. A lot of great answers. Remember, if you get something wrong, just hang out and chill and we'll have a fun time. So let's go grab this graphic and zoom in. A box plot is the visualization of what? A box plot, as I begin marking it right here, is the visualization. Great job, Jack and Caitlin right there. A box plot is the visualization of the what? A box plot is the visualization of the what? A box plot is the visualization of the what? A box plot of the 5-number summary. And it's great for comparing multiple distributions. But box plots sometimes hide important features that histograms show, because you can't see the shape so well with the box plot, but you can with a histogram. Histograms and box plots, univariate quantitative data. It's the same data, just being displayed differently. Histogram shows shape. Box plots sometimes hide important features. Why do I do that echo voice? If you've never come to our class, we call that a what moment. What moment do we call that when Brian goes in and says, box plots sometimes hide important features that you don't see, usually better seen in a histogram. Teaching to the test moments. Sometimes we go a little more direct to the test and kind of go a little bit like, I should write that down. So with this right here, make sure to write those things down, especially if you hear that. We're kind of going a little more test than usual on that. So with this, wait a minute. Something's wrong. I only have, maybe I should put it, why do I only have 4 spots? What's going on here? Maybe it goes there? What's going on here? I only have 4 spots. Now I have 5. What's going on? What's going on? Boom, Aaron, let's throw you. I'm gonna go out on a limb here and make you a mod. Why not? I'm just going a little crazy. Why not? Aaron, you are 100% right. It's because down here at the very bottom, this is the Q1 and it's also the min. A lot of people don't have a pet, so a lot of data is stacked up there. And then this is the Q2, also known as the median. I don't usually call it Q2, that is the median. And then we see here Q3, which this distance is literally the IQR. And then over here, we see that this is the max. What does this blue thing represent right here? What does that blue thing represent right there? This is a harder, it's kind of test relevant, but it's not the max. It's good, Aaron, good guess right there. It's not the max. That blue thing is not the max. The point right there is the max. Make sure outliers are part of the distribution. It's not Q3. Q3 is the top of the box. It could be 1.5 IQR above Q3, and it is technically 100 points. It is technically a 1.5 IQR above Q3 because the IQR is 2, 1.5 times 2 is 3. Moira, shouts to Moira, SI leader. Woo, Blakely's got it right there. We're throwing 100 points. And Blakely said it right there. It's the end of our data before outliers. It's the highest point that is not an outlier. It's like a point that is high that is not unusual. You could have bigger gaps. Like if there were not people who had pets up in this range, you could have the whisker go, like imagine if no one else had pets up here, the whisker could go to right there, and then you just have a big gap in your data, and this would be the highest non-outlier point. Does that make sense? Q1 and Q3 are the ends of the what. So repeat it again. Q1 and Q3, and I'll highlight it in blue for the answer. Q1 and Q3 are the whats of the whats. Q1 and Q3, good to see you, Sims. Q1 and Q3 are the whats. And we'll mention the 1.5 here again. Q1 and Q3 are the ends of the box. It is possible for mins and maxes and other values to be on top of those, but the ends of the box, the bottom is the Q1 and the top is the Q3. Now, when it comes to how far we put the invisible fences, and this is the number to memorize, the invisible fences will be how far away from Q3. So you go to Q3 and then you add a certain amount of IQRs above it. And you go to Q1 and you subtract a certain amount of IQRs below it. 1.5. But you can't have negative pets. So with this, there is no unusual amount of negative pet, or you can't have it. There is a technical mathematical calculation for unusual negative pets. It'd be -3 because the IQR is 2. And if you times 1.5 times 2, you get 3. So if you go 3 below, that is 1.5 IQRs because the IQR is 2. And so that would be an unusual amount of negative pets. But there is only a spot at which people have a very unusual high amount of pets. Someone who has, why is the median not 4 for the histogram? The median, it's just at 1. Good question. The median is the what of this graphic. I'll highlight it in blue. The median, really good question. The median is the what of this graphic. The median is the what of this graphic. Does the 5-number summary only apply to box plots? It can be used at any time, but the box plot is the visualization of it. Good answer. Bot, if they're, yeah, might block them here if they're a bot. The the median is the line in the middle of the box. The median is the line in the middle of the box. That's where the median is at. That's the median, and it's the 50th percentile of your data. 50% of people have 1 or less pets. 50% of people have 1 or more pets. The diamond, which is not always included, the diamond is where the mean is at. So that is the mean. We don't always include that because box plots are not required to include that. Jump includes it. And what do you notice about the mean to the median? When you compare your mean to your median, the mean is where? The last concept on this slide right here. The mean is where? Not all box plots include the mean. This one does. It's to the right. And what does that tell us? Since when you compare the mean to the median, so this is the median, and this is the mean, the blue is the mean. What does that tell you? The answer is it tells you this. What am I indicating? We'll do blue right there to show it. When the mean is greater than the median, it is skewed to the right. Because the mean, what's the what? The mean, what's the what? This is like, you need to have this, like the mean, and then you need to know that. The mean does what for 50 points? The mean does what? The mean does what? It is skewed right, but the mean follows the skew. Great job, Joseph, right there. The mean follows the skew. Whatever way it's skewed, the mean gets pulled in that direction. So the right skew indicates Monster Man lost his tooth. There we go, Monster Man. The mean follows the skew. Since the mean is greater than the median, this is indication of right skew in the data. Right to the high, left to the low, whatever way the Monster Man's tail goes. Negative, positive skew. Good questions right here. How can you find the IQR with just a histogram? It'd be tough. It would be more 100-point Moira question right there. You can visualize it. We have a slide that visualizes it. Like you would have to go in here and find where 50, see it's very hard to tell. The IQR and the median, or the IQR with just a histogram, I probably would have thought something like this, because you'd have to find out where the middle 50% is, and that can be very hard. What it is 75% of the data is below this line. How do I know 75% of the data is over here? How do I know that? Last question on this. W Moore, 100 points again. How do I know 75% of the data is below here? Using the box plot, I can tell this. Because that is Q3. Because that is Q3. Because that is Q3. So really good questions. It'd be very hard to tell with just a histogram because the box plot is the visualization of the 5-number summary, but box plots can often hide important features like what? Box plots are not good for understanding what? Box plots are not good, finish the sentence, for understanding what? And with just box plots, you'd have to look at the distances between these. And when you see it gets more stretched out here, that is an indication of right skew. Box plots are not the best for shape, but since it's stretched out to the high side, that is indication of right skew because the Q3 to the max, and also there's high outliers, indication of right skew, but the histogram makes it super easy to see. Histograms are better at showing shape. Box plots show the 5-number summary while hiding important features like the shape. Hopefully no one gets that wrong on the test. I know it's a question. Let's look at the leaderboard. We got Epic Swan, Caring Sea Lion, Amazon Gecko, Classy Snail, and Yellow Turtle. Good to see you on the leaderboard. Which of the following are true? Oh my gosh, I don't even know this question. I'm like, which one is it? Okay. We can use computers to simulate random events. Computers are sometimes needed to simulate complex events. Random events must be equally likely. Humans are good at generating random numbers. If I am correct, there are 2 trues and 2 falses here. Anyone ever play The Sims? Are you using a computer to simulate things? Anyone ever play a flight simulator? Is the flight simulator complex? So this is the one that usually gets people down here. Sims fan right there. We're all Sims fans, right? We're all living this. I'm just kidding. Random events do not have to be equally likely. Sims is OG, right? The OG right there. I do like some Sims. Shout out to Lazy Game Reviews. He does some great stuff. Random events do not need to be equally likely. The classic equally likely random event is a what? Random events can be equally likely, but random events, a classic random event that's equally likely is a what? Pretty equally likely. Now we said they can be randomly likely. They don't have to be. The classic random event that's equally likely is basically a what? We're doing charades right here. Go, boop. Coin flip right there. Great job, Thomas. Coin flip is like a 50-50 coin flip. Equally likely heads or tails. But if I go out and buy a lottery ticket, how many outcomes to a lottery ticket are there? You either what or what with lottery ticket, like heads or tails. When it comes to lottery tickets, you either what or what the lottery. So think, Brian goes out and buys a lottery ticket, you either win or lose the lottery. So with winning or losing the lottery, think about that. Is that equally likely? Is it as equally likely? Now you could say, but every individual lottery ticket, due to randomness, would have an equal likely chance of winning and losing. I'm like, okay, yeah, the probability of one lottery ticket is equal to that of another. But when we look at the outcomes are not equally likely. So random events, winning and losing the lottery, and this is the way to remember it, are not equally likely. So if you encounter this on the test, because no, I've seen that on the test too, random events are not equally likely. And please, 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 we've lost like half the people. If you're getting things wrong, hang out. Write down everything you get wrong. Random events do not have to be equally likely. The lottery is an example of a random event that is not equally likely. Humans are really bad at generating random numbers. One of my favorite examples to do that I do sometimes is I'll ask people to generate random numbers, and you'll notice that they don't come up with a good distribution. It's very skewed towards numbers they think are random, but not. Computers simulate random things like The Sims or other video games. Does anyone know what 3-letter acronym we call it in video games for the generation of random numbers? The random generation of numbers, the random number generation. Anyone know what I'm talking about? In video games, speedrunners hate it. They manipulate it. Little hippo manipo in RNG right there. So that's random number generation in video games. Very common. The video game might just choose a number, and the more random it is, it could be pseudo-random, but a lot of people have figured out ways to manipulate the random number generation by basically creating a seed. It's why when you watch a speedrunner, they'll like wait till a certain time to start a game, because it'll be like the internal clock on the game will then give them the same patterns. So they know exactly what's going to happen. And it's almost like they're playing a song when they're playing the game. It's really kind of cool. And computers are sometimes needed to simulate complex events. True, computers can do very complex simulations like flight simulations. Good stuff. Next question. Caring Sea Lion, Epic Swan, Blue Oryx, Amazing Alpaca with the party hat, and Amazon Gecko with the pancakes. But you look sad. Yeah, pancakes and syrup. Which variable is a special case categorical variable? Nice and quick one right here. We should go on to the next one soon after, so be ready. Special case categorical. Now, there are other ones that are also categorical, I do agree, but this is the special case categorical one. We will mention what all of these are. Does anyone know the only other variable on the screen that is also categorical? There is also one of these that is not like the super special case categorical. Does anyone know? One of the other ones on the screen is categorical technically. Nominal. Thomas on fire with those answers. It is nominal. Nominal is categorical variables such as like state you're born in. There is no order to it. There's no order. Now, if there's order, we call it ordinal. Like state preference. Nice job, Moira. So state preference would be something like rare, medium, medium well, well. Notice that there's a what to state preference. Ordinal. So what does it mean when we say state preference is ordinal? If we think about it as rare to well done, the categories go in what? To say something it's an ordinal categorical variable, the categories have inherent order to them. Great job, Sydney. So an ordinal categorical variable is categories that have order, where a nominal has no order. Nominal, ordinal. So they're different. Nominal has no order. State you're born in has no order. Or Tennessee, North Carolina, California, there's no real order to that. It's just a state. Meanwhile, state preference or freshman, sophomore, junior, senior are cases of ordinal. Continuous and discrete are specific kinds of quantitative variables. A continuous variable can have numbers or can have decimals, like how much of the pizza did you eat last night? Might be like 0.6. You ate 60% of the pizza. Where how many pizzas did you order last night is probably a discrete whole number. Like I ordered 2 pizzas. Or like how many bunnies do you own? Is that a discrete answer probably? Discrete quantitative or continuous? How do you think people would answer how many bunnies you own? Is that discrete or continuous quantitative? How many bunnies do you own? How much bunnies do you have? To go back to the original phrasing. How much bunnies have you? Is that discrete or continuous? What do you think? How much bunnies do you have? If we were to give stats numeric values, what would that be? Probably quantitative. Probably, Reese, message me if you want. It sounds quantitative right there. I think quantitative. If it's numbers, it's usually quantitative, but not for certain. And it'd be discrete, because if it was continuous, if it's continuous, then it would be like, I own 2.2 bunnies. Like, wait, what was going on here? Why do you have a 0.2 bunny? Or do I need to report you? So we would say I have 2 bunnies, 3 bunnies, 4 bunnies, 5 bunnies. Continue. It would be discrete because it's whole numbers. I have a lucky rabbit. Oh no, that's the 0.2 bunny. No, Pedro. I was going back to state your boarding question. Let me say that really quick here. If you were to give states numeric value, that would still good. Reese, good comment. If you gave each state a number, then that would still be nominal categorical. It'd be categorical because it's not how much is the state. It's just a group. It's just a group with a number. So Reese, really great question. It would still be categorical even if you gave the states numbers, because that's not how much of a state. It's just which state and you give it a number. So groups having numbers is not quantitative. It's still categories. And last but not least, please write down that identifiers. State number probably wouldn't be an identifier unless, Jack, there is the instance that it's like a database of states. Because if you had a database of states and then information for each state, the state would never what? So state is probably not an identifier unless you had a database of states and each state then had information across, because the state could not what if it's an identifier? It could not repeat. So there are theoretical ways to do it. And you're going to say, I'm going to pull up information on Tennessee, and then you only get Tennessee. Now, if you're looking at like driver's licenses, state would not be an identifier. What is your driver's license identifier? Like, what identifies your driver's license? Like, if they go to the database of driver's licenses and they're like, is state going to identify the person? Is gender going to identify the person? Your driver's license identification number, which will never repeat. They type it in, boop, 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 and there you go. That's you. So that's the point of it. Or, well, and plate number would identify the vehicle, or VIN number, vehicle identification number. VIN numbers will never what, or should never. There's a problem if they do this. VIN numbers, vehicle identification numbers, which are special case categorical variables, they're identifiers. VIN numbers will never repeat, and if they do, something bad is happening. And that's where you get into data integrity and problems, because they are meant to exist as a never repeating number to seek to identify. Special case categorical variables, identifiers. Let's check out the leaderboard with Caring Sea Lion, Blue Oryx, Amazon Gecko, Amazing Alpaca, and Yellow Turtle. Good to see you back on the leaderboard. Next question. Time plots are special case what's is. This is actually a multivariate time plot, but notice on the bottom it has index, as though we're checking it at hour 1, hour 2, hour 3, hour 4, hour 5, hour 6, and then we're looking at the data, how's it doing? So we're looking, good to see there, Maker. We're looking at the data and seeing what's going on. A lot of people confuse these graphics, so be very careful, because it is not a dot plot, it is a scatter plot. Scatter plot. A lot of people say dot plots. A lot of people say dot plots. So definitely, and I clue on these. Does anyone remember me saying that during class? Do not worry, 100 points if you got this wrong. So you're getting points just for being here. Dot plots are kind of like what's is. I'm gonna draw it out right here. When you think of a dot plots are what's. Tell me about that dot plot. I need help. What's a dot plot? What is a dot plot? A dot plot is where you literally just put dots like this. What are dot plots? Yeah, that's Rachel, good answer. And when do we use dot plots? Dot plots are used when? Notice how I'm drawing it over this? I'm drawing it over the histogram, which has a box plot above it. Oh, right there, Rachel, amazing answers. Rachel, keep it up. Because a stem and leaf shows you the numbers. Yep, so a stem and leaf would have the values inside of here. We're just writing some numbers inside there. But dot plots turn them into dots. So stem and leaves actually show you the values. They are univariate quantitative, as are histograms and box plots, but a dot plot just shows you the dots. What does a scatter plot look like? A scatter plot is the bivariate visualization of two what variables? A scatter plot is the bivariate visualization of two what variables? A scatter plot is the bivariate visualization of two what variables? Bivariate meaning two variables being displayed at one time, of two quantitative variables. Is this a time plot? Is this a time plot? Is this a time plot? No, because the x-axis does not have time on it. But what if this is my weight over this year? Is this now a time plot? What's happened to me this year? I'm Vulcan. It's Vulcan season. Is this now a time plot from Jan to March? Yes, now this is a time plot. It becomes a time plot when what? When does a scatter plot get? It's still a scatter plot, but now it has that additional thing of calling it a time plot, because time plots are special case what's where what? Time plots are special case what's where what? Good notes to have. These are the things you want to, when I do these whole blank things, you want to be like, time plots are special case blanks where the blank is blank. Does time have to be on the X? Exactly, Aaron. Good comments right there. Yes, the scatter plot becomes a time plot when we plot something over time. So we're looking at your weight over time. It's a time plot then. Like, how has your weight changed over time? Weight is quantitative and time is quantitative because we do distances between. You might say, but Jan 1st and Jan 2nd isn't a quantity, but there's one day between, because we can do mathematical arithmetic to figure out distances in time, and it is 24 hours, so you could technically like mark hour 0, I weigh this, hour 24, I weigh this. So if you want to get really technical, you can derive the mathematical time it is and compute the intervals. So this is a time plot right here, and it's a special case scatter plot where time is on the x-axis. Scatter plots, the visualization of two quantitative variables. What is a mosaic plot? What is a mosaic plot? I'm gonna draw one mosaic plot over here. What is a mosaic plot? What is a mosaic plot? A mosaic plot is bivariate categorical. You get points for being here. I hope. So let's go right here. Oh, we gotta do reverse. I hope it's something like this. So would anyone like it if this occurred? Sorry if you're not here right now. Would anyone like it if this occurred? Would you be happy if this is the way it goes? Would you be happy? Well, you're here. You're here. Who wants to get an A on the test? Who wants to get an A on the test? So this is, did you attend Kahoot? Kahoot attend. Did you attend the Kahoot? Think, you're here. That means people who attended the Kahoot would be what? People who attended the Kahoot would be what? So if you look within here, people who attended the Kahoot would be what? People who attended the Kahoot would be what? More likely to make an A on the test. People who attended the Kahoot would be more likely to make an A on the test. Where people who did not attend the Kahoot would be less likely to make an A on the test. So we could do a contingency table and ask questions on this. Of the students who attended the Kahoot, what is the probability? We'll put Kahoot here. Kahoot, yes, no. And of the students who attended the Kahoot, what is the probability they made an A? Of the students who attended the Kahoot, what is the probability they made an A? So you would say, like, you go, of the students who attended the Kahoot, what's the probability they made the A? So of the students who, keep asking questions, Rachel. This is making A down here. Of the students who attended the Kahoot, what is the probability they made an A? Of the students who attended the Kahoot, what is the probability they made an A? Of the students who attended the Kahoot. Anyone solve it? 75%. Show the math in the chat. Show the math. Of the students who attended the Kahoot, the probability they made an A. Does that make sense? 30 out of 40. What is the probability of a student attending the Kahoot? Out of, let's say, a smaller class, what is the probability of a student attending the Kahoot? So you can still do this. What is the probability of the student attending the Kahoot? Show the math. Try solving these. This is a marginal distribution. What is the probability of a student attending the Kahoot? Try solving these. So what's the probability of a student attending the Kahoot? Great job. 40 out of, there we go. And we can do a lot of different mathematics with this. Like, what is the probability of making an A? So what is the probability of making an A? 40 over 200, great job. What is the probability of making an A? The probability of making an A is what? I'm not gonna highlight this one for you. Notice I'm not asking two variables right here. Great job, Jack, right there. So it'd be this right here, and you go right here. For students who did not attend the Kahoot, what's the probability they made an A? For students who did not attend the Kahoot, what is the probability they made an A? For students who did not attend the Kahoot, what is the probability? I highlighted for you. There you go. For students who did not attend the Kahoot, what's the probability? That is a conditional. Given someone did not attend the Kahoot, what's the probability they made an A? Be careful. It'll be 60 over 160. Of the students who did not attend the Kahoot, what's the probability they made an A? So it's conditional. Make sure to do the 60 over 160 right there. 60 over 160. Does that make sense? Of the students. So you highlight that right there. You go across it. And you say, of the students who did not attend the Kahoot, you highlight that, and then you use the number here, the probability made in A over the total. So that's called a conditional distribution right there. Conditional distribution. The ones on the sides, because of where they exist, are the what distributions. The ones on the sides over here are the what distributions. Like these are called the whats, which is what's the probability of making an A, what's the probability of attending the Kahoot. Those are called the whats because they're in the whats. Not conditional. Those aren't the conditionals. Good guess. Those aren't the conditionals. Those are on the outsides. They're the marginals. They're in the margins. And you can see the marginal over here. This is a marginal and this is a marginal. Inside of this is a conditional and this is a conditional. So that's the conditional and these are the marginals. Those are the marginals and the conditionals would go like this right here. Conditionals go within a variable. So does that make sense? You can see the conditionals are highlighted in purple, going within one level and looking at the distribution of another, where the marginals are on the outside of the table displaying just one variable, a univariate display, like a stacked bar, like a bar chart. It is a bar chart, kind of one stacked bar chart, where the inside of, or the outside of the contingency table looks like a frequency table. Okay, kind of a long pause there, but that was a lot of information. Let's see how the leaderboard's doing. Carrying Sea Lion just galloping away or swimming away with those pancakes. Yellow Turtle, Epic Swan, Purple Giraffe, and Blue Onyx. Next question. Which distribution has the biggest range? Look carefully. Don't forget those outliers. Do not forget outliers. Do not forget outliers. Do not forget outliers. Do not. Look carefully. Someone's gonna be like, no. Like, they'll do like this. They'll be like, no. Someone didn't see it. Someone didn't see it. When you get to the test, do not forget about what's. When you get to the test, do not say it in the chat. Do not forget about what's. Lots of people didn't see it. Lots of people didn't see it. And the answer is very clearly on campus. I didn't even see it. Oh wait, Thomas, we gotta make Thomas mod now because Miguel's getting mad. Outliers, Thomas, let's make you mod. So do not forget about outliers. The outlier down here makes the range ridiculous. There is the min, there is the max. All others are totally destroyed by it. So the whole point of this is to remember outliers. Do not forget them. Whenever you're looking for range or min or max, it could be impacted by the outlier. What is a quantity not impacted by outliers? So like range, min, and max could definitely be outliers or impacted by outliers. What is a quantity not impacted by outliers? What is a quantity not impacted? The median. The median's not going to be impacted by outliers. There's another quantity too right near the median, which is not impacted by outliers. Median, great job, Sophie and Elizabeth right there. Median is not impacted by outliers. Correlation is. The median and IQR, great job, Ellie right there. Median and IQR are not impacted. Pretty much everything else is. Standard deviation is impacted by outlier because it's the typical distance from the mean, and outliers increase the typical distance. Good answers, 100 points for standard deviation, but standard deviation is impacted by outliers. Median, IQR are not impacted by outliers. The standard deviation, the mean, the min, the max, the range are all impacted by outliers. Next question, let's use in the leaderboard. Carrying Sea Lion, Yellow Turtle, Purple Giraffe, Funny Emu, and Rational Bunny? Little baby bunny. Rational Bunny, you're my new favorite. Win this for all the bunnies out there. Next question. Wait, you are a rational bunny and you are a bunny. Randomness for the win. Here we go with the next question. What is the best measure of spread for this distribution? Now, there's only two measures of spread you should think about. If you've already answered this question, please put the only two answers for measure of spread. There is a third one, not included on here, range, but I wouldn't use the range. So, what are the two measures of spread that you should only consider? There's only two plausible answers on the screen. If we say, what spread should we use? Weight spread? Wait. IQR and standard deviation. And how do we pick between those? When analyzing shape, center, spread, start by looking at the what? No problem, Jaden. When analyzing shape, center, spread, start by looking at the what? When analyzing, take this note if you don't have it. When analyzing shape, center, spread, start by analyzing the what? And Ellie's on the right track right there because that's an element of what? The shape, which is skew, which can be skewed. So because this is skewed, we will choose, sorry about that, MuBot, stop being mean to people. Good to see you there. Since, false positive, I don't know. Since it is skewed, we will use the what and the what respectively. Since this is skewed, no worries, Emma. Since this is skewed to the right, we will use the what and the what respectively for center and spread. We will use the median and IQR, IQR and median, whichever one you want to say, but median is a measure of center because it's the 50th percentile, and IQR is a measure of spread of the range of the middle 50%. So the median and IQR will be used respectively for center and spread. There's like 40 questions similar to Canvas content in the layout of question types and answers. So check out those Canvas contents, and we only have multiple choice here. Next question, let's do this. Carrying sea lion, yellow turtle, purple giraffe, epic swan. I got to 130. I got to keep going. Blue oryx, good work. Outliers can make a weak correlation strong. Outliers can make a negative slope positive. Outliers can make a positive slope negative. Outliers can make correlation weak. Outliers can make correlation strong. Outliers can make correlation negative. Outliers can make correlation positive. Outliers can take a perfect correlation and make it weak. Outliers can do this to correlation. Outliers can do that to correlation. What should you be writing? Catherine already knows this, and we know it every day here because we always say, you know what's up. Now you gotta be careful. You got Superman right here. Superman right there. Outliers can do anything. Outliers can do anything to what? Finish the sentence. Outliers can do anything to what? Outliers can do anything to what? Outliers can do anything to what? Correlation. I had a student who missed this, so I specifically wrote this next Kahoot question. We'll look at the leaderboard. First the leaderboard, then the question. Carrying sea lion, yellow turtle, purple giraffe, epic swan, and blue oryx. Where's the bunny at? Come back, bunny. Bunny, you got this. Outliers have their kryptonite. Outliers can dramatically impact the IQR and the median. Kryptonite, their one weakness. The outliers that want to destroy the world, they're the evil Superman. Outliers can impact the IQR and the median. Think of numbers. 1, 2, or 1, 3, 8. The median's 3. 1, 3, 10. The median's 3. 1, 3, 100. The median's 3. Outliers do not impact these values. This is false. False, 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 false. And boom, Jaden, great answers right there, Jaden. It's why we then use the median and IQR when there are outliers, because we say they're robust. They're like, it's a good robust way of doing it. What does robust mean? It means we like it, I guess. But we say robust in statistics, robust to outliers. Go ask ChatGPT, what does robust mean? Good to see you, Brooklyn. So outliers do not impact the IQR and the median. They go towards the central tendency in the data. The median and the IQR do. The outliers will not impact them. Hence, if there are outliers, as Jaden said, use median and IQR for center and spread, respectively. Next question, but leaderboard, carrying sea lion, yellow turtle, epic swan, purple giraffe, and blue oryx. Good work. Here we go. What is Q3 for this data? Look for the what of the what. So if you've already answered this, help people out by saying, go look for the what of the what. If you're looking for Q3, tell people you need to go look for the what of the what. Q3, some questions will say, which one has the higher Q3? The top of the box. And what does Q3 mean? Think about this. If you have 3/4, what do you got? What does Q3 mean? What does Q3 mean? What is it? It's 75th percentile. 75% of the data is 2 or below. So 75% of people have 2 or less pets. Doesn't that make sense? I have 2 or less pets. Do you have 2 or less pets? So 75% of the data is 2 or below. So we don't usually give locations on here. Good to see you there, Abhishek. Yeah, we don't usually give locations, but we're glad to have you here, and we're teaching some stats. So get ready for more stats questions as we check out the leaderboard. Carrying sea lion, yellow turtle, epic swan, purple giraffe, and blue oryx. Good job. Next question. Which of the following is not a condition for calculating correlation coefficient? We have a saying in our class. Anyone want to put the saying in the chat? I kind of put more than we usually say. There are 3 conditions for correlation. There are four regressions. So if you hear this fourth condition, you're learning something later. QQ straight enough, no outliers. QQ straight enough, no outliers. Those are the conditions. Let's talk about what they mean. Great job on the QQ straight enough, no outliers. QQ means the two variables you're analyzing are both quantitative. So to make a scatter plot and get the correlation, oh, no worries, Jaden. To make a scatter plot and get correlation, you have to have two quantitative variables, QQ. Then we have straight enough. It needs to basically follow a straight line, a curved relationship. Now I want to point this out. Let's even show it, because once again, it's one of those moments. Jaden, 100 points for everyone right there. Keep it up. So it's one of those moments where I do this right here with this voice. And I ask you this, true or false, the following has no association. True or false? This graphic has no association. I can't trick you. Start explaining it to me. Everyone's saying false immediately. Now everyone's gonna start saying false. I can't trick anybody. No linear. Oh my gosh, Sarah's already corrected for 100 points right there. That is true. The R value is equal to 0, but there is a parabolic form to it, a non-monotonic. That means it goes in more than one direction. Monotonic, your favorite boy band, One Direction. That's monotonic right there. Not normal. We wouldn't say really not normal. We would say it does not have linear. Thomas, 100 points. Good comments right there. This is false. There is an association. It's just not linear. Because if you think about something, time you bake a cake for and rating of cake, there's kind of an optimum time, but variation in the ratings, because not everyone's going to give it the top rating. But if we think about the rating up here, the rating is going to generally increase, and then you're going to burn the cake, or you're going to give someone cake batter. I mean, I don't mind cake batter, but most sane people don't like cake batter. Cake batter. I don't know. Raising Cane's batter. Next question. Let's do this. And no outliers means no outliers. Okay, association because the plot is, yes, the tightness. So Rachel, thank you for the clarification. I don't want to go too quick. But a stronger relationship is a what-ter relationship. Like this top plot right here is stronger than the plot below. A stronger relationship is a tighter one. And so, oh, thank you, 100 points right there, Amy. This one might only have R equal to 0.60, and this one might also have R equals 0.61. Now, why is this one stronger R, higher R? Why does this have a higher R than the other one? Yet this is the stronger, and this is like moderate. It's because it's straighter, because R only measures linear strength. The value of R that we find only measures the linear strength. So this has a non-linear form. So although it's tighter around its parabolic form, or excuse me, this one has a logarithmic or exponent log form. I think that's a log form. So I drew the actual form. This one follows the line. So if you draw its best form and you draw the linear form, they both follow. And so we can get an accurate measure of its strength via correlation. So strength is how tight the points are around the form. So the previous graphic right here is a strong parabolic relationship because the points are tight around the parabolic form. No, thank you. Good questions. Good questions. Next question. Here we go. What percent of track runners are expected to run at least 290 or higher? This is an empirical rule question. Get ready. The mean of the data is 330, and then find out where 290 is. 290, I'll try to point to it. If you notice 1, 2, and it says 290 or lower. It says 290 or lower. 290 or lower. You can narrow it down pretty quick. Oh, it says or higher? Oh my God, or higher. Well, the lower answer wasn't on here, so you couldn't figure it out if it was lower, because that answer's not on here. It does say or higher. So just compliment or take the other side of it. So I was like, where's the answer? I started looking for the answer. 290 or higher. So what you want to do, I know, right, Joe? This has scared me too. You want to do what they said on Full House. You want to draw it what? What's that famous saying on Full House? Draw it out. So draw it out. That's what we do. We draw it out. So whenever you get to an empirical rule question, you will use the numbers 68, 95, 99.7. Using those numbers on the screen right here, we take the curve and we immediately put our z-scores down below it. 0, 1, 2, 3, -1, -2, -3. We go in between for the 95% because that's in between -2 and +2. And then we say we are going above here. Now we would actually go through and beyond. So we do what I call the inside. Oh no, this is good. We did some during office hours, Rachel, check those out. Let me ask you this. Don't look at the numbers I have on the screen, but if 95% is inside of here, what is total outside? So we will give you the numbers 68, 95, 99.7. If 95% is inside, what is total outside? Good to see you, Emma, right there. 5%. And then we cut it in half, and that leaves 2.5 in either tail. The 5% is cut in half. And then you would add together to get your answer, because you want the amount above here. What two numbers should you add? You want everything. Great job, Rachel. Yep. You want to add what two numbers to get the area above here, because that's where 290 is at. 95 and 2.5 to get 97.5 exactly. And so it comes down to these practice. Check out office hours. I think we did a lot during yesterday's office hours or the day before. Check that out and practice them. Practice makes perfect on these, or better. You get better and better at them. What do z-scores of below 0.05 mean? It means that the thing is statistically significant, unlikely by random chance. Here we go to the leaderboard: Yellow Turtle, Carrying Sea Lion, Epic Swan, Blue Oryx, and Amazon Gecko. You're welcome. And what percent of the area on the graphic is shaded according to the empirical rule? Let's take a look. What percent is shaded? This is a really good follow-up. See pretty clearly. Yes. I'm gonna go look at that text. That's a special text noise. Surprised you could hear that. That was a Zelda text. Zelda text means I gotta look. Important text or Zelda text. Does anyone want to explain how to get this answer? If you look at it, we'll start drawing on this. I have enough time during this to solve it. We're going between 0 and 2, right? Good ways to solve in the chat. So in between -2 and 2 is 95. So what should we just do to the 95? Sarah has it right there, and so does Savannah. Lots of good solves. Look at all the different solves. Joseph went above and took 50% and said 50% is across here, and then Joseph subtracted off this area over here, which is 2.5, which we just found a moment ago. So you could literally use the numbers we just did to say 2.5% is above there. And great job, Rachel, that is actually how I solved it in my head too. So I did that solve, and then I really like Joseph solves too, that he said 50% is above 0, and then the 2.5 could be subtracted off. And then we've also in our class talked about that this is 34 because it's half of 68. So half of 68 right there, and then this is 13.5. You can start subtracting off the values. So you could add that up to get 47.5. So the more ways you can solve it, the better. I think the quickest solve on that is the 95 divided by 2. So really good work right there. And if you draw it out, it gets a lot easier on the test. Pro tip, when the test starts, flip over your paper, have your paper, and draw the normal curve. You can't bring it to the test, but flip over your paper and draw the normal curve when the test starts. Pro tip right there. Next question: Yellow Turtle, Carrying Sea Lion, Epic Swan, Amazon Gecko, and Purple Giraffe. Here we go. A stats 2-1 test is normally distributed with a mean of 75 and a standard deviation of 5. What percent make above a 70? Now, this time I don't give you the graphics, so you need to draw it out and be quick. We can have one piece of scratch paper. Yep. What do you notice about 70? Where is 70? So think 75 is the mean, and where's 70 in relation to 75? Below the mean, it's below the mean, and how far below the mean? 1 standard deviation below the mean. So you'd go back to your drawing right here, z-score of -1. Great job, z-score things immediately. Start z-scoring whatever you get. So we have the z-score of it. It's below the mean. You are below the mean or whatever this is. And we want to do above 70. So logically, your answer has to be more than what? More than 50%. Take a look. Take a guess. If you don't have it, take a guess. Good work. So here we go. It's 68. It's not quite 68. Good. Oh, wait, is that our friend from, are you our friend who's been here many times? I haven't seen you in a while. If so, hope you're doing well. So 68 is the number for between -1 and 1. So this is the empirical rule number. We go here at 0 and go down to -1, -2, -3. And we go up 1, 2, 3. And we do 68% is between positive and -1. Now the mean of the test with the normally distributed test was 75 with a standard deviation of 5. We then add the mean to the center of the data, and we get 75 here and 70. We now have enough information to solve because we draw our line right here at 70, and then we trace to the right. Now notice we go through the 68 and beyond, which means we need to figure out the remaining area above a z-score of 1. How are we going to do that? Well, if 68% is inside, what is total outside? Help me out, chat. If 68% is inside, what is total outside? If 68% is total inside, what is total outside? 68% inside, what is total outside? 30, 32. Jake, good work. You're thinking the half of the 68. Half of 68 is 34. So if you cut that in half, you do get 34. 32, and then we cut the 32 in half. Now, if you want to check these numbers, you can take all the numbers you found and see if they add up to 100% because you're traveling across the full curve. Now to find the area above a z-score of -1, we add together these two numbers here to get 84. And there's a lot of other ways to solve it, like 100 minus 16%, but the drawing is going to be the #1 way to solve these. So when the test starts, immediately draw it out. It will be posted, Ryan. Thank you for being here, 100 points. This will be posted right after it's done. Here we go with the next question. Let's take a look at it right here. Next question, leaderboard, yellow turtle carrying sea lion, epic swan, Amazon gecko, and purple giraffe. Let's do this. 68, 95, we will give you these numbers anyways, but it helps to know them. This is the area contained between 1 standard deviation, 2 standard deviations, and 3 standard deviations. Now, we have you at least know what these numbers are. We will give them to you on the test. But the numbers have additional decimals like 68.26, 95.449, and 99.7300. When we want to get the exact numbers, we will use applets, and we will show you applet pictures on the test. You will not use the applet on the test. You will get applet pictures, and you'll have to know how to look at them. Check out office hours where we've done a lot of those. 68, 95, 99.7. That is the area contained within 1, 2, and 3 standard deviations when data is normally distributed. Good answers. I think it's almost lightning round time. Yellow turtle, carrying sea lion, epic swan, Amazon gecko, and purple giraffe. Is it lightning time? It is lightning round. This is going to be the make or break on the points. And I will tell you this much. There is a question. If you are watching this, I'm going to do my voice. And it is a question that people get wrong every semester that I've literally put in this Kahoot. Have your note card out. Brian is literally going to read you verbatim a what during this lightning round. I am promising you now that verbatim, you are going to hear a what during this lightning round. Tell people watch the Kahoot, be like, he's doing test questions. He's doing it. He's doing the thing when he tells you a test question. I'm losing my voice here. I'm too excited. There's going to be what's here. What's there going to be? Got to hear it in the chat. What's there going to be? No one knows? No one knows? There will literally be what here? A test question. Let's get ready. Write it down. Here we go with the Kahoot question first. An ordinal number is a quantitative variable that has been sorted in ascending and descending order. An ordinal number is a quantitative variable that has been sorted in ascending or descending order. An ordinal number, quantitative. Ordinal number, quantitative. Anyone have comments on this? Ordinal number, quantitative. A picture of a watermelon cut out like a pie. It is false. It is false. It is false. It is false. Do not forget this. Yeah, Ryan, 100 points right there. What are you gonna do? I said I would do the voice. I don't like it when people miss questions. Here's the thing. You see this on the test, you're gonna remember this? I wanna hear it. If you see this on the test, are you gonna remember this? Ordinal, number, quantitative. If you see this on the test, are you going to remember it? If you see this, are you going to remember it? Yes. Ordinal data is categorical. Ordinal data is categorical data that has an inherent order to it, like steak preference from rare to well done. It is not quantitative. It is not quantitative. That is false. That is the thing that destroys this and turns it. Think steaks, exactly. They're categorical, ordinal categorical variables, not ordinal quantitative variables. It's a little tricky, but do not forget this. Get it right on the test and tell your friends. Have them write it down and know it. Ordinal data is categorical data that's been put in order, not quantitative. Next lightning round question. Who's in the lead right now? Carrying Sea Lion still up there. Yellow Turtle, Epic Swan, Amazon Gecko, and Adorable Impala looking cute there. Looking all nice. Got the cool hat on. Yeah, you're looking great. Here we go. Next question. Quantitative variables must be numeric. So if something is a quantity, it must be a number. Like, man, Brian's throwing these trick questions at us right now, right? Let me think of something like height. That's a number. That's quantity. Let me think of something as a quantitative variable. Okay, let me think. GPA, that's quantitative. That's a number. Let me think here. They have to be actual real numbers. Can I think of any examples? Like state you're born in. That's categorical. Quantitative variables are a quantity. Quantities are numbers. Yeah, that makes sense. Quantitative variables are numbers. That is true. Everyone's like, he's going to try to trick us again. No, quantitative variables are numbers. They're actual real numbers. Percentages scare me for this one. Yeah, it depends on how it's collected. Here's the thing. Always look to what was asked. Like, what class were you on the Titanic is a categorical question. Think about how someone would respond to that. Like, I'm in first class. That's how they talk. That would be categories. So you have to make sure you think about what is the response people gave. Don't worry so much about how it's summarized. Imagine you're asking the question like, how tall are you? And someone's like 75 inches. That's quantitative. That's a quantity of height. Next, our leaderboard. I got like 3 or 4 minutes till my meeting. So let's do this leaderboard time. And now, who's gonna win? A variable that consists of numbers is always quantitative. We get to the inverse of it. Something that consists of numbers is always quantitative. Like your student ID is a quantity of your student ID. Your driver's license number is a quantity of how much driver's license you have. Your Amazon order ID number, Jaden knows, is a quantity of how much order you have from Amazon. I have a 9.4 million order from Amazon. No, it could be identifiers, could be categories. Very false right there. Numbers aren't always quantitative, but anything that is quantitative must be a number. It's like humans aren't always male, but all males are human. So it works that way. Carrying Sea Lion, no disrespect. I need you to, oh, Joseph, I like that right there. Let's see right here. Carrying Sea Lion, Yellow Turtle, Epic Swan, Amazon Gecko, Adorable Impala. Here we go, 2 more questions. Let's do this. A bar chart is a good way to visualize identifiers. Here's a hint. Here's a hint. What do you not see on this screen? Here's a hint. What do you not see on this screen? What do you not see on this screen? What do you not see on this screen? This screen right here is showing you the different graphics. Boom, 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 boom. What do you not see? Yellow Turtle, congrats. We have review. So it is false. We do not have identifiers. We don't usually visualize them because there's no real thing to learn from them usually. There can be if they're time order collected or stuff like that, but usually we don't visualize identifiers. Identifiers just, there's special case categorical variables. You would just see a flat bar chart. It's not uniformly distributed. It's just that there's no variation in it. Everything's unique. So we don't usually visualize identifiers. There's no real point to it. What is the point of an identifier? What is the point of an identifier? Tell me the point of an identifier. Why do we have identifiers? God, he's back. What is the point of an identifier? To identify. Well, last question of the day right here with the yellow turtle carrying sea lion, adorable impala, funny emu, and bright otter. Last question. There is sometimes a good reason to remove outliers.
I'm back. I'm Tiny Brian. I'm here to announce the Kahoot. Woo! Tiny Brian back. Going off the screen. Sometimes a good reason. Like, don't remove me. Tiny Brian here. I'm the outlier in this data set. Sometimes a good reason, like someone tells you data. Tiny Brian, woo! I'm Tiny Brian. Like Tiny Rick. I'm Tiny Rick. It's an old TV show called Rick and Morty from season 1 or 2. Brian's references get old as semesters go on and students forget what the references are. I'm Pickle Brian. Turn myself into a pickle. Here we go. Leaderboard Tom, old TV show, you know, from back in the day when I was growing up, Rick and Morty. Wubba lubba dub dub. Leaderboard time, there is sometimes a good reason to move outliers because sometimes they're lies or miscommunicated and we sometimes have to correct them or remove them, but we should always mention why we remove them. We have yellow turtle, carrying sea lion, and adorable impala. Brian's gonna tell you a little bit more and then head off.
Oh my gosh, Tiny Brian made his first appearance at a Kahoot in a long time because he wasn't correctly reconfigured. With that, I want to say a huge thank you to everybody. Make sure to email me and let me know if you got in first, second, or third. We've got the Amazon or Starbucks gift cards. Email me from your UTK email account and swing by for a t-shirt if I have your size. Yay for you. If I don't, I'm sorry. But let's do a really fun outro right here. We're going to do our Star Wars outro. So if you haven't seen it, Star Wars outro to end the day. Thank you, everybody. Bye for now. Bye. We've almost got these new intros ready. We're almost there.
This has been going for like 20 hours. This ends now.